Hello and welcome to our What's New in SAP HANA Cloud webinar. My name is Thomas Hammer and I'm the lead product manager of SAP HANA Cloud. And I'm super happy to once again give you an update about the latest innovations that have been added to SAP HANA Cloud. Now, in this webinar, we want to focus on the deliveries that have been introduced to HANA Cloud via our first quarterly shipment of 2022. So this is the March edition, basically. And in the webinar, we will talk about single highlight innovations that we would like to point out as they have been part of the latest release. So that means also that, of course, what you're hearing today are very important functionalities from our perspective, but definitely the entire release contains more innovations and more great features that have been added to HANA Cloud that are worth being discovered. So during the session, I won't just be on my own. I will have several product experts on board that will guide us through the new innovations that have been added to HANA Cloud, and that will also give great demonstrations about the functionalities and how they can be used in HANA Cloud. So I'm very much looking forward to that. And also, of course, in the course of the webinar, we will share additional materials with you of how you can get started with these functionalities and where you can find more information. So on the slide here, you can already see the speakers that will talk to us today and that will introduce some of the great highlights that we have shipped with the latest release of SAP HANA Cloud. Let's take a quick look at the agenda. So we have split the webinar basically into two parts. As usual, we will first of all talk about the SAP HANA Database as part of SAP HANA Cloud. And then in the second section of the webinar, we will talk about the data lake. And in both sections, we will deep dive into specific innovations that we have introduced with the Q1 shipment for SAP HANA Cloud. And then in the end, I will wrap it up, giving you some more insights into other innovations that we have introduced and provide a few new news to you, and also give you a few resources at hand, as said, where you can discover more information. And now, basically, without a lot of further ado, I would like to directly start with the very first topic. And as you can see on the slide, it is about machine learning in HANA Cloud, our integrated machine learning capabilities. And for that specific deep dive, I'm super happy to hand it over to Christoph. Christoph, take it from here. Let's see what's new in SAP HANA Cloud.
Thank you very much, Thomas, and also a warm welcome from my end. I hope you are able to see now my screen. So I'll introduce you the new capabilities in the area of machine learning in SAP HANA Cloud, the predictive analysis library, and other capability areas. So our key feature highlight is around the ability to build pipeline models which are composite predictive analysis library models composed of multiple function codes calls in a sequence you can use for training and prediction of such model. And on top of that, an AutoML framework, which basically allows you to generate automatically the best pipeline across pre-processing steps, model fitting, and comparison of different algorithms, and optimizations of parameters for these algorithms for classification and regression scenarios. So that's a huge step forward and highlight for this release in the area of machine learning. We have SQL interfaces for that, as well as Python interfaces. The benefits are, of course, we now can have far more sophisticated models composited of multiple functions in pre-processing, as well as different algorithms. And we can leverage that automation framework to come up and with the best possible model and parameter selection and sequence of different algorithms, and just call this from calling a single Python or SQL function call. This yields in far higher productivity for the experts, the data scientists, or also developers using the SQL function interface, and the ability to come up faster with better models yielding in certainly improved or optimal business outcome and business value of applying the machine learning models. So you can see here the Python interface side of this automated machine learning framework, which you also see in the demo live. How does this now map to the existing capabilities? We have pi function in different areas. Classification is one of the key areas where we'd like to predict a category value, like is a customer likely to churn or behave fraudulent, or regression where we predict a continuous value, where we'd like to, for example, predict a car price for a model based on the car characteristics we are knowing. For these scenarios, we have a bundle of different algorithms where the expert knows what is the advantage of one algorithm over the other, or what is the constraint of one algorithm compared to the other. And to simplify usage and embedding into application, we have built in the past the so-called unified procedure interfaces for classification and regression, which allows the application developer to use the same procedure and doesn't require then the application to change the call interface into the predictive model, because we're using always the same shell, while we may change the algorithm or the algorithm configuration. Now, the AutoML framework on top of that allows to build these composite models with a sequence of algorithms in that pipeline and that automation framework to come up then with the best possible pipeline or model configuration. Here we can now see the SQL interfaces and procedures to the AutoML framework to configure, create, and fit, or so as we say, train these pipelines. The first call here to the PAL pipeline fit function in the first gray box basically takes a pipeline JSON model, which we have created as a string here, and pass that into that pipeline fit model. If we don't have that JSON string for the pipeline we'd like to fit, we can use the next function here, the PAL AutoML config function, which we can use to compose certain pipeline configuration, in this case for a regressor model, where we can then add or drop or change the configuration of certain algorithms we'd like to use, and then again create a JSON, pass the JSON, then in the next step to the AutoML fit function, which then trains different pipelines in parallel or sequence and comes up with the best possible pipeline. The third gray box here then again does the same, while we pass in a given pipeline again as a JSON string into the PAL AutoML fit. So for example, we have come up with the best possible pipeline, then we can use this pattern of a call to then retrain the best possible pipeline, maybe on a bigger data set. There's also then options for inspecting the progress of such an AutoML run, which may take a little bit longer as we're probing a larger number of variations. And in the Python interface, as we will see, then also provide some visualizations and reports on the different pipelines evaluated. Apart from the AutoML framework, we also have enhancements in the area of regression and classification. Our unified function interfaces now support implicit handling of missing values and changing, imputing missing values. We also support a new mode, which we call segmented of massive execution, where we can train regression and classification models, in this case, in parallel based on by group we specify in the data. So it's a performance feature if we want to train a larger number of models in parallel based on by groups we can identify in the data. We support the same, as we can see, in the area of time series analysis and forecasting for ARIMA, AutoARIMA, and the additive model analysis algorithm, the profit algorithm, where we also support this massive invocation and segmented time series forecasting based on by groups in our data. In addition, in time series analysis for intermittent demand time series forecasting, we support a new variant of the Croston function, which yields better forecast results as it evaluates the probability of demand in the upcoming period versus only looking at the length of the next period. And then for volatile time series, there's also some enhancements in the Garch time series functions. In the area of text mining, we now support, in addition to German and English, support Spanish as the next language with our text mining and text classification and text analysis function. And also for the automated predictive library, APL release 2203 is adopted in HANA Cloud Q1 with also some additional functions in the area of model export and probing for single exponential smoothing functions. Our Python machine learning client has a series of enhancements again in the area of data frame. They're listed here, but you can also inspect them in the documentation, like feature generation is added upsert with in the process of data frame creation, adoption of new parameters in the PAL algorithms, and new algorithms like isolation forest has been added, which was introduced in Q4 in the HANA Cloud release for the predictive analysis library. Also, the automated predictive library has some enhancements in the Python machine learning client, like in the area of variable selection of parameters, and German as a language is added to the text mining functions in the Python interface. And then certainly the big topic is the AutoML framework and how it's been used from the Python machine learning client. And we'll see that now in the demo I'd like to show to you. Here I'm using a Python Jupyter notebook. And in this Python Jupyter notebook, I will show you the new capability based on a scenario, which is a classification scenario. So I'd like to predict a category value. In this case, I have a sample patient data set, and I'd like to predict or build a model to predict the likelihood of patients to acquire diabetes. So as a first step, what I do, I import the latest version of the HANA ML Python machine learning client. It's 2.12. And next, I'm actually connecting against the HANA Cloud system here. I'm being prompted for the password, the way I configure the connection, and I'm getting the information. I'm actually connected to HANA Cloud, and you see as the version 2204, which is the Q1 release number, if we want, or release version. Next, I'm uploading the data set here to my HANA Cloud schema, and I'm creating a data frame, DF, it's called here. And as we see here, for those who don't know, Python and the data frame, a data frame is basically a select statement against some data in HANA. If I'm now issuing the collect method, then I'm actually transferring a result set of that query using the head method to filter the data to 6 rows, which I'm now have been transferring here to the Python side. I see I don't have an ID column in my data, and I'd like to rename also my target column, which is the outcome, my classifier, which I'd like to predict. 1 is a patient acquired diabetes, 0 is a patient didn't acquire diabetes. So that's my target column here, the last columns. But now we come to the interesting part. I'd actually like to build the AutoML classification method. For that, I'm loading the package class, automatic classification, and building my automatic classifier instance, providing some parameters, population size and offspring, kind of define how many variants of pipeline do I want to train in parallel or in a sequence. And what is my target metric measuring the quality of the pipelines I've been building for evaluation. So I've set this, the object is created, and now what we apply is basically what operators do I have or do I want to use in this automatic classification. As you can see here, we have operators in different areas, column transformers, classifier, and resampler. And as we are configuring now the scenario, we don't want to use any resampler as we have a very small data set, but we want to drop some of the column transformer. We don't have any category columns. However, we want to use some feature selection methods here and some column value scaling methods as well as variants to our model, to our pipelines. And then in the area of classifier, we want to drop some classifier like decision tree and support vector machine. But we still have hybrid gradient boosting, multi-layer perceptron, logistic regression, and random decision trees. However, we aren't happy with the standard value ranges of the parameters. And for that, we use the update config methods to basically change that parameter space for the algorithms in focus. And with that, we have actually set our AutoML configuration, which we can expect here. And next, we will run it and monitor the progress of the different pipelines being built using the pipeline progress monitor. And as we can see here, we have a simple scenario because of the demo time we have. We've built 15 and 8 and another 8 different pipelines models in about 9 seconds. We can then look at the best pipelines. I said I want to have a look at the 5 best possible pipelines, specifying the elite parameter before. And I can see here, I have a random decision tree classifier combined with a scaling function in one of the pipelines, logistic regression, etc. So different pipeline models here created. If I wanted to know what actually happened on the HANA database side, I can inspect the last executed statement. And in there, I do see a secret script anonymous block. And in that, I actually see the PAL AutoML fit function, which we have seen before on the slide. And with that, I basically almost like to conclude. There's for data scientist experts also a report where we can expect the different statistics around model quality, inspect the pipelines and the parameters graphically. And certainly, we can also have a look at the model created as we know it from PAL function, the pipeline model now here and how it would be stored in a table. And certainly, there's also a predict model which we can use to predict on new data based off the best pipeline model we are using. And with that, I'd like to stop and hand over to the next speaker, which is Jan on calculation view modeling. Thank you.
Also, a warm welcome from my side. I will focus now on the new features that are coming with QRC 1 in the area of calculation views. These features will be released with the database version of QRC 1. However, because these features also appear in Business Application Studio, you also need a current release of Business Application Studio that's coming in April, in the beginning of April. We will also share a project that I use here for the examples. So you can then later take this project in your system if you are on QRC 1 and execute the same or look at the same examples that I show here. The features that I will talk about are coming from different areas, from the area of data preview, federated scenarios, performance, and also model insights. The first feature that I want to talk about is about the data preview in Business Application Studio. And per default, if you start a data preview, a default query is executed. That means you get all of the columns of your view per default in it, and you get no filter in it. This can be something that is not wanted because you might be interested in a more restricted query, so you are only interested in certain columns, you want to apply certain filters. The problem is the query is executed automatically, which means you have no chance to modify it before. And this means then you have a query that is uninteresting and that might take up quite some resources because there's no filter on it and all columns are in it. Now you have an option to control this behavior. If you go to the preference section, you can switch off the automatic execution of the SQL statement during data preview. And if you do that and you choose the manual option, then you have to explicitly request a refresh of your data. So you have the chance then to modify the query and adapt it to what you are interested in without executing an expensive query beforehand. The second one is also about data preview. It is now possible to show graphically hierarchies that are modeled in the view. This gives you an easy way to check hierarchies, whether the data that is in the hierarchy is what you expect to be in it and how the hierarchy looks like. The prerequisite here is that it is an SQL hierarchy view available, and this is created automatically if you define a hierarchy. So you see here one hierarchy defined. If you then select here the option of hierarchy type auto or SQL hierarchy view. In a federated scenario, you often have the situation that you are consuming a remote view and you want to make sure that as few data as possible is transferred to your target system. For that, it's important that you can use filters in the remote source already. And we now opened up the possibility to map input parameters also to remote views. That means you have now better control of where a certain filter should be applied. For example, in the remote source, you can already use this input parameter for filtering so that the data is only coming over the network to the target system after having been adapted to your query. The prerequisite here is that you're using SDA for the connection and, or technically speaking, the HANA ODBC adapter, and that the remote source is at least on SAP HANA 2.0. In the area of performance, we introduced a new pruning option. I mean, pruning options are generally speaking a way of reducing the data processing very strongly early, which means in a typical case, if you have a union pruning situation, you know semantically that if a query asks, for example, for a certain year, that only one data source might be of interest. So you can remove all the other data sources during query processing very early, and by this get a better performance. Now we have added another pruning concept, and that's the column pruning concept. And in this concept, you define certain columns as being relevant for your query, and you are not interested in data sources that don't contribute to this to these focus columns that you are interested in. That means if you select the focus column and the data source does not contribute to this focus column, then the data source is pruned early and excluded from processing. Here's an example. You see here two data sources. You see one containing data from 2019, one from 2020. The important point is that the focus column sales is not mapped from 2020, which means if you execute the query, this data source can be excluded pretty early because it's not contributing to what you are interested in. Often, if you want to do refactoring decisions, it's important to understand where are certain parameters or other elements like calculated columns or restricted columns used. You have now the option to select your element and ask for where is it used by this button. So for example, here you see that the input parameter year is used in the aggregation node and in the calculated column year short. With that, it should become easier for you to make decisions about refactoring and get better insights into your models. With that, I switch over to the demo. So here you see the project that I was talking about before that we will share with you later. In this project, the individual features are shown by example, and they are structured according to the features into the several folders. So if you open a folder, for example, here for column-based pruning, you see the file info. which is for every folder one. And this info file, you can have a more detailed look with a markup language, doing a data preview here, and then you can see the description of these examples, which hopefully help you to understand the features better. Now, the first demo that I wanted to show you here is about the column-based pruning. And here in the union node, you see, first of all, that the sales column is not mapped to the output here. It's only mapped from the first source. So the data source 2019 contributes to sales, while the data source 2020 does not contribute to sales. The focus column here is sales, and we switched on column-based pruning. This means now, because column-based pruning prunes away sources that are not relevant for the focus columns, that the sales orders 2020 should be pruned away and excluded early from processing. Let's have a quick look how it looks like if I do a data preview. So what we expect is that we see only data of 2019 now, because 2020 is irrelevant for the focus column sales. So let me put years on the abscissor and sales on the ordinate. And what you can see here now is that only one year is appearing. The other one is pruned away. You can also verify that by doing an explain plan. So if you look in the explain plan, you see that only one single source is taken here, and that's the table sales orders 2019. The other one is pruned away. The next feature that I want to show you is about the hierarchies. So we have here an hierarchy view, a view with an hierarchy. The hierarchy is defined in the semantics as you usually know here in the hierarchy. So there's one. And if I do a data preview, I will now see in the data preview screen also the hierarchy option, the hierarchy tab that will appear here. And I can just select the existing hierarchy of the view, drag it here, and now I can navigate in this hierarchy. If you're interested in the SQL statements behind this navigation, you can click on this button, and this gives you the SQL statement that delivers these values. So this can be of interest for you if you want to develop your own SQL statements using this hierarchy view. Then you can base this on such examples here. Another feature that I shared with you was about the automatic refresh. And if you remember, if I did a data preview here, for example, on the column-based pruning example, the data was immediately fetched. So the SQL statement was run automatically without my interaction there. So let's just have a look again at it. So you see, if I now switch to raw data, it's already executed. Now I can go here to File and Preferences and search for manual. I did that before, so that's already here. And then I can click here that I want a manual refresh. Now, if I go back and do a data preview again, you will see that I have to explicitly ask now for the data. So this gives me now the chance to adapt the query to the query that I'm interested in before it's executed. So for sake of demonstration, let's go to the raw data. You see it's empty and I have to explicitly request the data. Then about the where use function. Here we have the calculation view. I close all the close others. I close the other tabs. And if I now navigate to the semantics and I select an element, like for example, the input parameter here, I have the option to ask for where it's used. And you see here now the years used in aggregation in the calculated column year short. So this gives me now an impression of, or a better insight on what is going on in this model. The final thing I want to demonstrate you also how to use this info file. So as I showed before, you can open this info files, click on the data preview for the markup language, and now you can read here what is the intention behind this feature and also see the example. So you see, for example, here, I just close this here and make this a little bit larger, that you can better read it. So you see now here the input parameter of the current view, and if and this input parameter is mapped to the remote view, to the input parameter there, F1 in this remote view, which is reached via virtual table, and the same here. So this input parameter at runtime will fill the value into these two input parameters of a calculation view and an SQL view. And if you want to test that then on your system, you can just take the statement and execute it, and then you will see that whatever you enter here as a filter will be executed then as a filter in the remote source. With that, I'm finished with my demo, and I hand over to Ralf, not before saying thank you for your attention.
Yeah, thanks a lot, Jan. Very interesting what's happening here on that level. And now we go a little bit deeper into the operation of HANA Cloud, and want to look into the offerings of new offerings of HA. As you know, last year, 2021, we ended with very nice 3 combinations. I listed here for repetition, and to make it clear, we already have a very nice offering. We can offer high availability with staying in one availability zone in the upper right. We have DR across 2 availability zones with an asynchronous replication option and the combination of both. All of this is still sitting in one single region, often also named metro area. So imagine Frankfurt, area Frankfurt or area Tokyo. So the data centers are apart something up to 10-20 kilometers. And this offering we now want to extend with Q1 2022. We want to start with a multi-zone high availability, as it's shown here, MZHA. Here we want to bring the very nice and very useful synchronous replication to 2 availability zones. So far we always had an asynchronous replication in between the availability zones. Now we want to have synchronous replication between the availability zones, and this gives us very interesting options we will see on the next slide as listed. So this is very helpful. And with these nice synchronous features, we plan and have a new SLA for this special offering, synchronous multi-zone replication, with an uptime of 99.99%. This is simply based on the synchronous features. You know, with the synchronous feature, we can always assume that the secondary has exactly the right committed state. And with that, they are totally in sync, and at any point in time, we can do takeovers, autonomous takeovers, and so on. So the synchronous replication gives us these autonomous automatic failover features. We had so far only in 1 availability zone, now across 2 availability zones. And of course, after a takeover, the re-establishing of replication is happening for sure. Because they have the same committed state at the end. On the right side, you see a screenshot how this looks like in our Cloud Central in the creation wizard. You, of course, first have to define a source. Here you can assign it automatically as usual, as before, and then you can decide between the different availability zones we have in the different locations or regions. Afterwards, here on the next slide, you see what's happening afterwards. You can add another replica. You can decide if I would like to have this replica synchronous or asynchronous. And accordingly, I can choose another availability zone. data center you could imagine. I also here could choose to use an automatic selection. What's important to know is there is no combination of multi-zone HA and DR options because they are simply replacing each other, simply because they cover the same area of usage. And the DR combination with multi-zone HA might come. It's probable, very probable later on in the journey when we start to go multi-region. Then you will have the option of multi-zone HA in one region and going to another region with DR again. But right now, today, as is shown in the first slide with a collection of the options, there is no combination of multi-zone HA with DR. And also the GUI is reacting accordingly. If you want to switch between these different setups, then it will automatically reselect then the right data centers. And you can also again then decide if you go to synchronous, you will choose first of all as a default setup the 1A, the same as the source, and then you can override it with a different data center or availability zone as you wish. If you would like to change existing installations, you have to drop the replica and create it from scratch new. If you do so and you choose on the source side for an automatic assignment, as it's mentioned here, downtime is to be expected, at least for now. We are working on that. In future, this situation probably will get better. And another thing you have to keep in mind, you need a certain minimal version of the HANA Cloud database. Otherwise, if you are below or earlier than 2142, then the Cloud Central will not present at all these options. So keep in mind, you need a certain minimal version for these options. And the next thing is you might also come up and see such a warning here in this selection, simply because we are not only HANA Cloud. HANA Cloud needs a lot of support outside in the infrastructure, and accordingly we have here also an infrastructure cloud service, and he's also running in these 3 availability zones we have in a typical location for HANA Cloud. And if you are choosing one of the or this one availability zone where this infrastructure service is running, it might have side effects in terms of failures. Imagine you put your secondary together with this service in the same availability zone, and then you might see situations that these services are also hit by the outage, and this you probably want to prevent. So it's good to go for the other availability zones in this case. But of course, first of all, it would work. But in case of an emergency failure, then it might have a side effect. So it's a temporary situation. The plan is fixed, like we do a lot of behind the curtains, a lot of optimizations also in the plant maintenance windows, ongoing process planned for the year to get rid of these maintenance windows, planned maintenance windows as far as possible by consolidating these maintenance windows, using more and more near zero downtime options, as you already can choose for these things, for these takeovers and updates already now. That mentioned, it might be that you want to combine this new multi-zone high availability together with an already existing application server setup, application server layer, whatever it is. Here you might think about synchronizing. If an application server needs to fall, that also the HANA multi-zone HA should fall or should do a takeover. For that, we introduced, as it's seen here on the right side, a start takeover option, a manual takeover option. With that, you will see a pop-up coming up, and then you can start the takeover over there. So quite easy. The takeovers are very fast. I tested it several times in the meantime, and it's in the area of 10 seconds, maybe 15 seconds. So it's really, really fast in contrast to the on-premise system application options, where we typically said it's taking around about 2 minutes. So quite an advancement here with the new options in HANA Cloud. So what does it mean? We also need to update these kind of setups, and of course we would like to have a near zero downtime update process here, and I can tell you it's in place, and I would like to explain it here shortly in this overview. So of course in front of or before the upgrade we have two systems into availability zones. On the right side you see the HA replica having the same software version. The first step is that we place an off-site or off-place installation on the primary side using system replication. We know from the past from on-premise, we are using it in the same or similar way here in HANA Cloud. We bring this up to speed, to the right version, of course, first, and then do a synchronization in between. And in the next step, we do a takeover from this first line to this new software version, takeover happening, and afterwards we recreate the HA replica in the other availability zone. So from the end user perspective, there's always a system in reach. The only thing which takes a little bit is to build up the HA replica here, and for that I expect to see more nice features in the future, to have multiple replicas here. This is also on our roadmap to fill even further gaps you might have imagined in the past. Of course, with that said, I would like to hand over to Thomas for the next part. Thanks.
Thanks a lot, Ralf, and also thanks to Jan and Christoph for giving us some insights into the innovations in the area of the SAP HANA Database as part of SAP HANA Cloud. Now let me briefly take over the screen again. Now, as said, next topic for us is a deep dive into the SAP HANA Cloud Data Lake, and of course we also want to look at highlight innovations that we have introduced in this product area. And basically the first deep dive goes directly into the area of tooling and the tooling support for the data lake in SAP HANA Cloud. And for that purpose, I would like to hand it over to Dan, and he will then later on give it over to Robert, who will give us some more insights into the data lake relational engine. So Dan, first of all, stage is yours.
Thank you, Thomas. Let me just quickly share my screen and I'll get started. Just give me a moment here. I seem to be having some technical problems. Oh, there we go. Okay, yes, hello, my name is Dan Van Leeuwen. I'm a member of the SAP HANA Product Management team, and I'm pleased today to be able to demonstrate a new feature in the SAP HANA Database Explorer that enables the ability to create a connection to the data lake file container. Once this has been created, you can then browse the file container. You can upload, download, and delete files, as well as examine the contents of text files within a file viewer. So this provides another way to interact with the data lake file service in addition to the REST API and the CLI. Let's get to a quick demo. Okay, so here's my Database Explorer, and I've got 3 different connections shown. The first one is a connection to a HANA database. The second is a connection to a relational data lake. And the third is to the data lake file container. And as you can see, I can browse the contents of the data lake container. I can choose to upload a new file. In this case, I'm going to pick a CSV file that contains some sample hotel reservations. Once the file has been uploaded into my file container, I can then see the file here. If I wanted to look at more closely into the contents of my data lake file container, I can choose Show Files. And here I can see the different content of my file container. In this case, I have a file, reservations.csv. It's around 5 megabytes, and I can see the last modified time. Once I select the file, I can choose to download the file. I can upload a new file. I can delete the file or refresh this view. Once this file, again, is in my file container, I probably would next want to query the data within that file, and I can use something called SQL on files to do that. So to do that, I will open a SQL console, and let me paste in some SQL and give a quick demonstration of that. So the first thing that I'm going to do is create a remote server, and then I will create a schema within that server. And then finally, I will create a remote table. So I can now browse and see the contents of the SQL on files. I can see the tables and the table that I've just created. Let me open that up. The one thing to note about a remote table is that it has a data source, one or more data sources, and that is something that we will do next. We will associate the CSV file that we've uploaded into the data lake file container with this remote table. Another thing to note is that it is also associated with a virtual table, and the virtual table is the table that you would then use within a SQL query. So we will also create that next. And so this command here will associate the CSV file with the remote table and add it as a data source. We'll create the virtual table. And then finally, we will create a select against that virtual table that we've created. So that virtual table is created here within the catalog. You can see it. And if I execute the SQL query, it is going to return all the different room types that are of type suite and whose arrival was before February 28th of 2021. And let me just resize that a bit. And there we go. Okay, so in summary, storing structured data files in the file container provides cost-effective storage for less frequently accessed data or data of unknown value. SQL on files allows you to perform SQL queries on the structured data files. The data that you wish to access more frequently can be moved into the data lake relational engine or the HANA database. To find out more information on this, you can see the tutorial Getting to Know SAP HANA Data Lake File Containers, as well as the product documentation. So with that, I'd like to now hand over to my colleague, Rob Waywell.
Thanks, Dan. Let me just share the next slide here. So we got a few more new features for Data Lake we want to highlight this quarter. And these are for the Data Lake, the relational engine component of the Data Lake. And just a heads up for anybody who maybe isn't aware yet, we have updated the name of the Data Lake relational container from Data Lake IQ. And in part, that's to reflect the extended capabilities relative to the traditional IQ capabilities, such as the SQL on files capability Dan was just highlighting. So for folks who are using the relational engine, then key things we're adding this quarter. Number one is customer-facing diagnostic files. You know, with the managed service, there's a lot of the diagnostic files aren't relevant to the customer anymore. They're relevant to the operations team within SAP, but there's still a bunch of information in diagnostic files that are relevant to individuals who are building applications against the data lake. So the diagnostic files that are exposed here, you can access them through the HDLFS client utility. So we are storing these diagnostic files using the HDL files storage ourselves. You can also access them through the REST API. So the HDLFS client utility is just a simpler way to get to them from a command line without having to go through, a REST tool. You can also access them through the SQL console, although I'd say that's the least readable format. When you retrieve them using a stored procedure through the SQL console, you actually get it back in base 64 encoding. So I'd go with the client utility, the REST API. You'll get server logs, query plans, the IQ message file in particular we return right now, and the HTML query plans, so giving you the detailed query plan execution plans. You also get server startup information, so table loads, deletes, truncations, transaction IDs, information like that. The next feature is still related to diagnostic type information, but a different focus, which is database auditing. So this is auditing user activities on the database. The flow for that is coming straight from the documentation there. So you have to enable the auditing as a trace session. Create a diagnostic service key because these, while stored in an HDL files container, it's a specific one for the audit information. It's not just generically dumped. So you have to create your diagnostic service key, and of course that is only available to the owner of the instance. Create the trace events, and you do have control over what gets traced for auditing. So it can be all database activity, or you can optionally limit that to only tracing connections, only tracing DDL statements, or permissions grants or revokes or triggers. Right? Audit files themselves are retained for 30 days. And again, you can get to those using the REST API for HDL files or using the client utility, the HDLFS client utility. And in order to get the most human readable form, once you've downloaded the file, then there is a DB manage ATD utility that lets you read those easily as a human readable format. And then finally, last one we want to highlight for Data Lake this quarter is we are introducing self-service upgrades. So by default, if a user does not upgrade so you have not had the self-service ability until now. In previous releases, upgrades for the Data Lake were forced upgrades 40 days after the QRC release. All right, so as of the QRC release, you could create a new instance and you'd see all of the new functionality. You could be doing your testing on that new instance, but existing instances would be force upgraded after 40 days. With the QRC1 release, now you will have the option of executing that upgrade as a self-service upgrade at a time of your choice. Right? Forced upgrades are always done during a maintenance window, of course. So in the UI, if you're looking at HANA Cloud Central, and you go to the ellipsis here on your Data Lake instance, whether it's a standalone instance or a managed instance, you will now see an upgrade option there. All right. Looking forward, near zero downtime upgrades are currently planned for Q2 release. So that will be a further enhancement for the Data Lake going forward. And with that, I will pass it back to Thomas.
Perfect. Thank you so much, Robert. Thanks for passing it over to me again. And thanks, Robert, to you and also to Dan for giving us a deep dive into a few of the highlight innovations that we have introduced to our Data Lake as part of SAP HANA Cloud. Now, let me basically wrap up this webinar and give you some more insights apart from these very specific topics that we wanted to highlight for the HANA database as well as the Data Lake. One more innovation that I would like to highlight from my side is about the new possibilities for automatic user creation using JSON Web Tokens or the security assertion markup language via so-called LDAP groups. While we've been supporting the authentication for the SAP HANA database already using LDAP mechanisms, we now also support the possibility for automatic user creation, as said, via LDAP groups and via JWT and SAML. So this is a new functionality that enhances the possibilities in terms of user authentication, and as said, also the user provisioning that happens then, of course, in the background automatically. So from my perspective, a great complement to the already very comprehensive security and authentication mechanisms that we offer. Now, last but not least, more or less, I want to highlight a few more additional resources that we definitely will also share with you via the resources of the webinars, but also via other different means and links and blogs. So what you can find here on the screen is definitely the comprehensive link summary of all the materials that are probably of interest for you. So first of all, I would recommend checking out our What's New in SAP HANA Cloud document. This is a document you can find on the help portal and on our product page for SAP HANA Cloud. In there, all changes introduced with the new Q1 release of SAP HANA Cloud are outlined in detail. So not just the highlights that we presented today, but basically the entire scope of the release. Apart from that, we typically with every release also provide a product update blog where we try to summarize all of the highlights and all of the great functionalities that we have introduced with HANA Cloud. That one you can find in our SAP community for SAP HANA Cloud. Definitely check out the community and see what's being published over there. And if you make sure that you also, let's say, subscribe to the community and to the community text, then you definitely don't miss such very valuable information from our end. And apart from that, also the blogs and the tutorials and the information and the materials that you've seen during this webinar today will also be shared and communicated with you via the resources, or it is linked here on the page. And with that, I already want to let's say, close this webinar. I want definitely not to miss thanking our presenters for their very great deep dives into the specific functionalities on the one hand side related to the HANA database, but on the other hand side also related to the data lake. So thanks a lot for that. Definitely also a big thank you to all the participants who joined our webinar today. Thanks for tuning in. It's always great to see such a big number of people being interested in the latest innovations introduced for SAP HANA Cloud. So thanks a lot for that. And we're looking forward to seeing you very soon again. In case you have any further questions or would like to discuss any further topics, please make sure to reach out to us. You're always very welcome. Thanks from my end and have a good day.